Hello everyone. In this video we will see the depth first search algorithm or the DFS algorithm, and I will show an example applying the depth first search algorithm on this particular graph, and we will see how the traversal order will look like. The main difference between depth first search and breadth first search algorithm is in depth first search we are utilizing a stack data structure and we will be performing the push and pop operation. In the case of breadth first search, it was a queue data structure and we had performed NQ and DQ operations. That is the only difference between the depth first search and the breadth first search algorithm. Now we will go through an algorithm for depth first search or DFS. So in order to start the algorithm, we first need the graph itself and a starting node. And in the algorithm, we need to create a stack, then we will initialize that stack to be empty. Then we will push the first node or the starting node into the stack. Then we will mark that starting node as visited. After that, we will run a while loop. We will run the while loop as long as the stack is not empty. After that, we will pop an element from the stack and we will give that to a variable v. Then we will investigate all the neighbors of the node v and we will call those neighbors as w. Once we get a neighbor, then we will check whether the neighbor is visited or not. If it is not visited, then we will push that neighbor into my stack. Then we will mark that neighboring node as visited. The order in which we pop the nodes from the stack gives us the traversal order. Now we will go through the step-by-step execution of the algorithm in this particular graph. So we will select the starting node as the vertex A. So E gets the value A. Then we are creating the stack and after that we are making it empty. So our stack is empty now. Then we will push the starting node into the stack. So the stack contains its first element as A. Then we will mark that vertex as visited. So I will mark A as visited. Then we will check whether the stack is empty or not inside the while loop. So as the condition for the while the stack is not empty, we will pop the top of the stack using this instruction. Then we will give the popped node into the variable v. So v also contains a. Now as we have popped the stack, we will get rid of this a from my stack. So we had taken out the vertex a from the stack, so that makes the first entry in my traversal order. So the order in which you are popping any vertex from the stack will give the traversal order. So the first popped element is A. So A is the first entry in the traversal order. Then we are investigating all the neighbors W of the vertex V, or in our case it is A. We will find all the unvisited node, then we will push it into the stack, then we will mark it as visited. So here we have the neighbors of A as B, E and D, and none of them are visited as of now. So we will have to push all of them into the stack one by one. So first we will push the vertex B into the stack and we will mark that B as visited as per the instruction, this one. Then we will push the vertex E into the stack, then we will mark it as visited. Then I will push the vertex D into the stack, then I will mark it as visited. So we have done with this part as of now. Then we will go to the condition for the while loop again, whether the stack is empty or not. So the stack is not empty, so I will be popping the top of the stack. So then that popped value will be assigned to the variable v. So we will be popping the value d because the stack is a last in first out or the LIFO data structure. So we have to take out the vertex d. So I will be taking out the vertex d, then that. So we are popping the value d from the stack. So this will get removed and this d will be here. So the next entry in our traversal will be the vertex d. Now we are investigating all the neighbors of d. So the neighbors of d are now a and g, out of which a is already visited, g is not visited. So we will push that g into the stack, then we will mark that g as visited. Now we do not have any unvisited neighbor for the vertex d. So we have done with this part. We will be going back to the while loop again. Now we will investigate whether the stack is empty or not. So the stack is not empty, so we'll pop an element from the stack and assign that to V. So we will be assigning G into V. Now we will write this G into my traversal order. So the traversal order is now ADG. Now we will investigate all the neighbors of G. So G has three neighbors, D, E and H. Out of them H is not visited, so I will be adding that H into my stack, then we'll mark H as visited. So we have investigated all the neighbors of G. So this part is over. Now we will check whether the stack is empty or not. So the stack is not empty. Then I will pop the topmost element of the stack, that is the node H. So I will take this H, then I will write it over here. So we have popped an element, so that comes as the next element in my traversal order. Now we will investigate all the neighbors of H. So H has got two neighbors, they are G and I, out of which the node G is already visited, I is not visited. So I will add that I into my stack and mark I as visited. So we have done with the node H by investigating all of its neighbors. Then we will go back to the while loop. Then we will check the stack is empty or not. The stack is not empty, so you take out the top of the stack. So I am taking out the stack entry I. So I will be assigned to the variable V. Then that I will be added to the traversal order. Now we will investigate all of the neighbors of I. So when you look at this one, when you look at this, then I does not have any unvisited neighbor. The only neighbor it has is H, and H is already visited, so we do not have to do anything at this section as of now. Now we will go back to the while condition to check whether the stack is empty or not. The stack is not empty. Then I will pop the top of the stack. So I am popping the element E from the stack and assigning that to the variable V. Then I will write it in the traversal order. Now we will investigate all the neighbors of the vertex E. So E has got three different neighbors, A, B and G, and when you look at the visited array, all of them are visited. A is visited, B is visited, as well as G is visited. So we do not have to do anything in this section. So we will pop the stack again. So we are popping the stack by taking out the value B, and that B will be assigned to the variable V. That B will be returned into the traversal order. Now we will investigate all the neighbors of B. So B has three neighbors, A, E and C. Out of them C is not visited, so I will add that into the stack, then I will mark it as visited. So we have done with this part as far as the vertex B is concerned. Now we will go back to the while loop to check whether the stack is empty or not. So the stack is not empty, it contains an element C. So we will pop that element and assign that value into the variable V. So we are taking out C, then we are marking that C for V. We will write it in the traversal order as the next entry. Now we will investigate all the neighbors of the vertex C. So C has two different neighbors, B and F. Out of them B is visited, F is not visited, so we have to push it and mark it as visited. So I am pushing the vertex F into my stack, then I am marking it as visited here. So we have done with this section. Now we will go back to the while loop again. So while loop is checking whether the stack is empty or not. So the stack is not empty, so we will pop the top of the stack and assign that value into the variable V. So we will take this F from here, then we will write that F as the value of V. So we have written a value for V, or we have popped it. So that comes as the next entry for the traversal order. So that is the entry F. Now we will investigate all the neighbors of F. So F has got only one neighbor, that is C, and C is already visited, so we do not have to do anything at this section. Then we will check whether the stack is empty or not. So here the stack is empty, so it will not go into this while loop, it will exit out of the while loop. So that makes the end of our iteration of the while loop. So this is the order in which the nodes will be searched in a depth first search traversal.